We've all seen the image, a cosmic whirlpool pulling everything into a center from which there is no escape, a one-way ticket to a point of infinite density. That's the clean, terrifying picture of a black hole's interior that general relativity gave us. But what if it's all an illusion? What if quantum mechanics, physics' other master theory, is telling us there's nothing inside a black hole at all, and that everything we thought we knew about them is wrong? To get this cosmic mystery, first you have to appreciate the classic picture, the one painted for us by Albert Einstein. His theory of general relativity describes a black hole as a spot in space-time so warped by gravity that it creates a boundary of no return, the event horizon. Anything that crosses it, a star, a planet, even light, is locked on an irreversible journey inward. According to general relativity, that journey only goes to one place, the singularity. This is a point so mind-bogglingly dense that space-time curves to infinity, and our laws of physics just give up. The work of Roger Penrose and Stephen Hawking showed that for any star that collapses into a black hole, a singularity is pretty much inevitable. This story is clean, elegant, and frankly, horrifying. It gives the black hole a definite interior, a silent, dark piece of space, totally cut off from our universe, leading to a physical dead end. For decades, that was the accepted story. But then the universe's other great theory, quantum mechanics, crashed the party. And it brought a paradox so deep, it threatens to break our whole understanding of black holes. In the 1970s, Stephen Hawking discovered that black holes aren't completely black. Thanks to weird quantum effects at the event horizon, they slowly leak particles, a glow we now call Hawking radiation. This radiation makes the black hole lose mass and, over an almost eternal amount of time, evaporate completely. Here's the catch. A fundamental rule in quantum mechanics is that information can never be truly destroyed. But Hawking's math suggested the radiation coming out was random, carrying zero information about what fell in. This is the black hole information paradox. Think of it like burning a book. You might think the information is gone, but in principle, you could rebuild the text from the smoke, ash, and heat. Hawking's work implied that if you throw that same book into a black hole, the information vanishes from reality forever, something quantum mechanics absolutely forbids. This set up a battle of giants between relativity and quantum theory. To solve it, physicists came up with some wild ideas. One of the most shocking, proposed in 2012, was the firewall. This is a highly contested theoretical idea that suggests, in order to save information, Einstein's smooth event horizon doesn't exist. Instead, it's a searing wall of high-energy particles that would incinerate anything that tries to cross. In that scenario, there's no interior because nothing could ever survive to get inside. So if a black hole's inside isn't a one-way street to oblivion, and it's not a wall of fire, what is it? The answers coming from the edge of physics are stranger than you can imagine. One of the leading speculative frameworks is the holographic principle. This idea suggests that all the information about what fell into the black hole gets encoded on the 2D surface of the event horizon, kind of like a 3D movie being projected from a 2D film. That three-dimensional interior we picture becomes just a projection, an illusion. The real black hole is a complex tapestry of information woven onto its surface. Another mind-bending and also speculative concept is black hole complementarity. It suggests there isn't one single reality. To an observer falling in, the interior is real, and they pass through the horizon smoothly, just like Einstein predicted. But to someone watching safely from the outside, that same person and all their information look like they get scrambled and stored at the event horizon. The idea is that both points of view are true. depending on where you're standing. More recently, breakthroughs involving quantum extremal surfaces suggest a mathematical way for information to be preserved. These calculations show how information inside the black hole is profoundly linked to the radiation outside. It doesn't provide a simple escape route, but rather shows the interior is real and quantum mechanically tied to the exterior, saving the information without needing a firewall. Even more current research from 2025 into theoretical BTZ black holes hints that the interior might be a bizarre, non-orientable spacetime, like a Klein bottle, where space and time can flip their orientation. If these cosmic puzzles get your brain buzzing, make sure to subscribe and hit the notification bell for more trips to the edge of what we know. What do you think is at the heart of a black hole? Drop your best theory in the comments below.